Let's talk about rhombuses, or rhombi. You can actually say either one. Merriam-Webster tells us that the plural of rhombus is either rhombuses or rhombi, so it's your choice whichever one you want to use. A rhombus is a parallelogram with 4 congruent sides. Now, notice that that definition says that it is a parallelogram. And think back to what we learned in our previous lesson about parallelograms. We learned a lot of information about them. So the fact that a rhombus is a parallelogram tells us that it has all of these characteristics. So a rhombus has 4 congruent sides, that's true, but it also has everything that we already learned about a parallelogram, including that its opposite sides are parallel, its opposite sides are obviously congruent because all 4 sides are congruent, its opposite angles are congruent, its consecutive angles are supplementary, and its diagonals bisect each other. And then there's also 2 interesting things that are also true about rhombuses in particular. One of which is the fact that their diagonals bisect each pair of opposite angles. So we already knew that the diagonals cut each other in half, but now we're learning that if it's a rhombus, then the diagonal cuts each angle in half. And since the opposite angles are congruent to each other, each of these 4 little angles are congruent to each other as well, because this is the angle bisector of BAD, and it's the angle bisector of BCD, and if those 2 original full angles were congruent, then each of the bisected angles are congruent. And same idea with these 4 angles as well. So if it's a rhombus, the diagonals cut each angle in half. And we would also know that the diagonals of a rhombus are perpendicular to each other. So in addition to all of the characteristics of parallelograms and the fact that rhombuses have 4 congruent sides, we also know these 2 extra characteristics, which is that the diagonals bisect each pair of opposite angles and that the diagonals are perpendicular. So let's put all of this new knowledge to use. Which side is JK congruent to? Well, it's congruent to all 4 sides. That's the definition of a rhombus. If this is a rhombus, then all 4 sides have to be the same. And then I get some students every year that get confused about, well, that must mean that all 4 sides are parallel as well, and that obviously isn't true. That's just the opposite sides that are parallel. Obviously, JK and KL are not parallel. You can see their point of intersection. So just refer back to the definition of parallelogram for this answer. JK is parallel to ML, and that's it. KN would have to be congruent to MN, and that's the diagonals of a parallelogram theorem. The diagonals of a parallelogram cut each other in half. Since a rhombus is a parallelogram, we can say that KN must be congruent to MN. Let's talk about the angles. Angle JML would have to be congruent to angle JKL, because those are the opposite angles of that rhombus, and a rhombus is a parallelogram, so we can use the opposite angles of a parallelogram theorem. Angle JMK is congruent to, well, LMK for sure. These 2 angles have to be congruent to each other because the diagonals of a parallelogram bisect each angle, but since, as we just said, the opposite angles are congruent, that means that when the diagonal bisected this angle, it also created 2 congruent angles that were congruent to the original 2 angles. All that is to say that all 4 of these angles are congruent to each other. And what about angle JNM? JNM is one of the angles created by the intersection of the diagonals, and we know that the diagonals of a rhombus are perpendicular. So that would mean that actually all 4 of these angles are right angles, so all 4 of those angles are congruent to each other, because of the perpendicular diagonals of a rhombus theorem. Okay, let's solve for each of these variables. If PQRS is a rhombus, then what's A, and B, and C? Well, they would all be 18, because if it's a rhombus, then all 4 sides are congruent. But does that mean that all 4 angles are congruent as well? Are D and E and F all 72 degrees? No, we only know that opposite angles in a rhombus are congruent to each other. So F would have to be 72 because it's the opposite angle from angle P. But then how do I figure out D and E? Well, they are consecutive angles with the 72 degree angle that we were given, and I know that the consecutive angles of a parallelogram have to add up to 180 degrees. They're supplementary. So D and E would each have to be 108 degrees because of the consecutive angles of a parallelogram theorem. Alright, let's see what we can do here. G would have to be 54 degrees, because SQ is one of the diagonals of this rhombus, and we know that the diagonals of a rhombus bisect the opposite angles. So if this part of that angle, PSQ, is 54 degrees, then the other half would also have to be 54 degrees, because PSR was cut in half by diagonal SQ. H would have to be 90 degrees, because it's one of the angles formed by the intersection of the diagonals, and since it's a rhombus, the diagonals are perpendicular, so H would have to be 90 degrees. So then how am I supposed to figure out I? Well, at this point we would know that G is 54 and H is 90. That makes this little triangle right here a right triangle. And we know, according to the corollary to the triangle sum theorem, that the acute angles of a right triangle add up to 90. So I can say that 54 plus I equals 90, and that means that I must be 36 degrees. And that's all you need to know about rhombuses, or rhombi. In our next lesson, we'll be discussing rectangles.